All right, so welcome to Unit 5 of the fall semester of PreCal for seniors. So this is our first day of notes, which um, we're going to call these identities. So they're, in other words, called proofs. What you're trying to do is show how the left side of your equation equals the right-hand side. So you're not manipulating both sides like you do with algebra, but you are kind of substituting things from this box. So kind of keep this box handy with you. A lot of this you already should have memorized. The one thing that's kind of new is this fact that sine squared plus cosine squared equals 1. The reason for that, but there's just a rule that if you ever see sine squared plus cosine squared, that's automatically going to equal to 1. And it's only plus, doesn't matter the order, it could be cosine squared plus sine squared, but that's always equal to 1. Well, you can also manipulate that equation by subtracting cosine on both sides and getting something that looks like this. That means that if you see sine squared, that's equal to 1 minus cosine squared. Something that I should have added onto here is that it does matter if it's squared. If you just have sine of x plus cosine of x, it does not equal 1. It has to be squared. This has to be 1 minus cosine squared for it to be sine squared. You can also subtract sine squared on both sides and end up getting what cosine squared equals to. What's also crazy is that you can take that same identity and manipulate it to get some new ones. So like, for example, if you were to take the 1 equals sine squared plus cosine squared, and if I were to divide everything by sine squared, you would get 1 over sine squared, which is cosecant squared, sine squared over sine squared, which is just 1, and cosine squared over sine squared, which is cotangent squared. And again, you can manipulate that by adding and subtracting stuff on the other side. What you can also do is you can take that same equation, 1 equals cosine squared plus sine squared. And what happens if I divide everything by cosine squared? I get a brand new equation that says that 1 over cosine squared, which is secant squared, is equal to 1 plus tangent squared, because cosine squared divided by cosine squared is 1, sine squared divided by cosine squared is tangent squared. So that sine squared plus cosine squared can go and be manipulated to get all sorts of different types of equations, especially two new ones that you use different trig functions with. But these three identities are going to be important for you to know. These are three that usually are given to you on any kind of assessment in this class. So again, don't let me say the word proof and kind of scare you. What you want to do is you want to change the left-hand side by doing substitution of things that you see in the box above. And make it to the right-hand side. And this statement's always true. It's not like you can do this and be like, oh, it's no solution. No, this is always true. So my advice to you is to always get these in terms of sine and cosine. Cosine of x is already cosine of x. But tangent of x, if you remember from the unit circle, is y over x. But y, the y value, y coordinate from point from your unit circle is sine, and x is cosine. Or you can see in the box up here, where is it at? Oh, right here. Tangent of x is the same thing as sine of x over cosine of x. You can kind of do the same thing with cotangent. You can also do the same thing with any kind of reciprocal functions. You can do any of that. And then you math it. Well, if you multiply cosine by something that's divided by cosine, those cancel off. So you end up getting left with sine of x, which is the right-hand side. So that's it. That's what an identity is. Again, my advice to you is to get things in terms of sine and cosine. Secant is the same thing as 1 over cosine. Cotangent is the same thing as cosine over sine. And again, you can find all of this stuff in the box above. In the box above, it also says that sine is 1 over cosecant, but we don't want to change these to the other trig functions. We want to put them in terms of sine and cosine. Now notice that I'm showing all my work. I'm putting the variable, which is going to be very important. So what happens here? Well, if you're, again, multiplying and dividing by the same thing, they cancel each other off. So what are we left with? 1, which is the right-hand side. And that's all you need. So you already know the answer. The answer is the right-hand side. However, you need to be showing how does the left-hand side become the right-hand side. Now, you will get a lot of practice with this to figure out, like, okay, well, which of the things do you do above? Like, if you see sine squared, yes, it's equal to 1 minus cosine squared. But it might not be the easiest thing to do for this. So what I'm going to do, since I know what's going to happen to this, is I'm going to make sine squared the same thing as sine times sine. Secant, I'm going to change as 1 over cosine. And then cosecant, I'm going to leave as 1 over sine. Well, if you notice what ends up happening, one of our sines is going to cancel off with one of these divided by sines. So when I multiply what's left over, I'm left with sine of x over cosine of x, which on its own is tangent of x, which is the right-hand side. So again, your final step, your final line in all of this work is to show that that left-hand side is the right-hand side. I did not do anything to the right-hand side. I just showed how that all becomes tangent. And now what we're going to do is we're going to kind of get into some more challenging problems. So what I'm going to do is I'm going to replace tangent with it in terms of sine and cosine, which again is sine divided by cosine. Cotangent on its own is the same thing as cosine over sine. Now I have two fractions that are equal to each other, or that are being added to each other. So what do I do in order to get those to add up? Well, I need a common denominator. The common denominator for this would be one of each of those denominators. So that means I need to multiply this by sine of A over sine of A, and multiply this by cosine of A times cosine of A. Now, what does that allow me to do? Well, it allows me to add these two fractions together with a common denominator of sine of A cosine of A. Well, what happens to the top? Well, you have sine of A times sine of A, which is sine squared. And then you have cosine times cosine, which is cosine squared. Now, again, there's no reason for us to break this up to sine times sine again or cosine times cosine. What you should realize is you have one of these new identities. Sine squared of an angle plus cosine squared of that same angle is always going to equal to 1. Well, to be very helpful with you in your notes, what I want you to see is that, so these two trig functions are being multiplied down here. And when you're multiplying fractions, you just multiply the top times the top and the bottom times the bottom. So I can break this up to 1 over sine times 1 over cosine, which 1 over sine is the same thing as cosecant. 1 over cosine is the same thing as secant, which was the right-hand side that I was trying to show this equals. So there are a lot of different ways that you can do this. There's more steps that you can show. There's less steps you can show, but just the idea here is to allow anybody to look at your work and flow along with what you're doing. If you're going straight from this step to this step without showing what you're multiplying by, you're not showing all your work. You need to be having a sound kind of proof on why that left-hand side is the right-hand side. All right, then what about number 5 here? Now, I could change both of these to be in terms of cosecant, but again, my rule of thumb for these is to get all of these to be in terms of sine and cosine. So cosecant is the reciprocal of sine, and I'm going to leave sine alone. Or really, I'm going to put over 1, just because it's going to be helpful. I'm subtracting two fractions. I need a common denominator. The common denominator between these two fractions is sine of x. So I'm going to multiply the top and the bottom by sine of x. What does that help me do? Well, I'm going to end up getting a fraction that has a common denominator, sine of x. On the top, I'm going to subtract 1 minus sine squared. Well, if you look in your box above, you can see how we manipulated sine squared plus cosine squared equals 1 to 1 minus sine squared is equal to cosine squared. but I'm trying to get this to be cotangent times cosine. Well, what's crazy is I already have a cosine, so I could kind of take out a cosine from the cosine squared and end up getting something that looks like this. Well, cosine over sine is cotangent, which is the exact same thing as what I have on the right-hand side, just, different order. Order doesn't matter, but that is how we do that identity. All right, so a lot of comments that I make on people's work with this is that they forgot how to math. So what I want to ask you is if I were to tell you to distribute this 2 into that equation, how would you distribute it? Yeah, you would do 2 times 3x and 2 times 4. What I get some people doing with this next problem is that they'll do the 2 times the 3, the 2 times the x, and the 2 times the 4. So what I'm going to show you is I'm going to take this tangent function and multiply it to these two terms. This whole thing is one term. It doesn't matter if there's a multiplication or with it, or division even. This is one term, sine is the other term. So when you multiply that out, you have tangent of x times sine of x. Then you have tangent of x times cotangent of x times cosine of x. So that cotangent cosine is almost like 3x. You don't distribute the 3 to the 2 to the 3 and the x. You just multiply it 2 by 3x, and you get 6x. Same thing that happens here. So like all the rest of them, I'm going to change these in terms of sine and cosine. So tangent is sine over cosine. Leave sine alone, and I can put over 1 if you need me to. Tangent is sine over cosine. Cotangent cosine over sine. And then cosine. There is no problem of showing more work. The idea is to make sure that anybody can look at this and see what happens. Well, another thing that a lot of students forget to do is just order of operations. Some people try to add first, but you need to multiply first. So you end up getting sine squared of x over cosine of x. Then you get plus, well, I have a sine and a sine here, a cosine and a cosine there. So really, I'm just left with cosine of x over 1. But just like the previous two problems, I have two fractions that I'm adding or subtracting, in this case adding. I need a common denominator, so I'm going to multiply the top and the bottom by the common denominator, which is cosine of x. The top ends up being sine squared of x plus cosine squared of x. And you're going to see me move this up a little bit because I'm running out of room. But something that you learned today is what sine squared plus cosine squared is equal to. It's 1. So we're left with 1 over cosine, which is the same thing as secant, which is the right-hand side. Now, the problem here is that you cannot skip steps, okay? Please just try to show as many steps as possible. If you're doing too much in your head and you're going straight from this to secant, that's not a rule. There's no this fraction equal to secant in the box above. If you look in the box above, you actually do have how 1 over cosine is the same thing as secant. All right, so here's another example. So if I distribute this out, we have sine of x times cosecant of x, and then sine times sine, which is sine squared. Well, something in the box above, you can kind of see how if you're multiplying something by its reciprocal, you get 1. And in this case, sine and cosecant are reciprocals of each other, so those multiply to 1. So that's something that you can easily do. What I could have done in the last problem is shown how tangent times cotangent is 1, and that would have been done. And then what do I do from here? Well, I don't need to change anything in terms of signs because it's already sine, but I can use one of those pieces in my box above that says that 1 minus sine squared of x is the same thing as cosine squared, which is the right-hand side, and I'm done. So some problems might need more work than others, or problems might be as simple as this. So that's distributing. The opposite of distributing is factoring. So notice how we have these two terms have a secant squared in common. So I'm going to factor that out. Well, when you factor something out of itself, you're left with 1, and then plus tangent squared of x. Now, I could go about this trying to change this to sine and cosine, like change tangent squared to sine squared over cosine squared and try to get a common denominator and go off from there. Or you can look in the box on the last page and see that 1 plus tangent squared of x is the same thing as secant squared of x. So I'm going to use that substitution and end up getting secant squared of x times secant squared of x. Well, secant squared of x times secant squared of x is almost like x squared times x squared. You add the exponents and you end up getting secant to the 4th. So the crazy thing about PreCal is how we use all sorts of type of math that we have learned in the past and apply it to these kind of weird problems that you might not have seen before. Now, these do take time to get good at. Remember that what you need to be doing is you need to look at this box and use the substitution that we've been doing. Like I've been using cosecant as 1 over sine, or like the two reciprocals are being multiplied equals 1, using these new, what we call Pythagorean identities. Just practice them. Don't copy people.